Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P16BD, specifically pertains to a malfunction in the starter cut relay 2 of the Honda Odyssey models from 2011 to 2017. This relay plays a crucial role in ignition system operation, ensuring the starter system functions correctly. Located in the driver's under-dash fuse relay box, this component acts as a switch, enabling or disabling power to the starter motor based on signals from the powertrain control module PCM. The PCM, which is the vehicle's central computer, monitors various systems and signals, including those related to engine starts, and influences relay operation. A failure in the starter cut relay may impede the ability to start the engine, leading to potential troubleshooting needs. There are specific steps outlined for diagnosing and resolving issues when encountering this DTC code, which should be approached systematically to ensure accuracy and efficiency. The error associated with DTC P16BD involves a malfunction of the starter cut relay 2. This relay's primary function is to control the power supply to the starter motor, which is essential for initiating the engine start process. The starter cut relay connects to the powertrain control module, PCM, to receive the necessary signals to operate. The physical location of this relay is in the driver's under-dash fuse/relay box, making it integral to the vehicle's electrical architecture. A malfunction may prevent the engine from starting, leading to various diagnostic requirements that must be followed to efficiently diagnose the issue. The relay itself is involved in ensuring that power only flows to the starter motor when conditions are safe and appropriate for starting the engine. Several factors can contribute to the occurrence of DTC P16BD, each needing thorough examination. Firstly, poor connections at the starter cut relay or its terminals can interrupt electrical flow, leading to the malfunction being reported. Loose terminals at the starter cut relay 1, starter cut relay 2, and the PCM should always be inspected, as these can create intermittent issues. Next, a blown fuse can also signify problems within the system. If the fuse protecting the starter cut relay circuit is compromised, this could prevent relay operation. Each component must be carefully checked as part of the troubleshooting process to determine if these concerns are responsible for the DTC's activation. The symptoms associated with DTC P16BD primarily revolve around the engine's failure to start. Drivers may notice that when the ignition is turned, there is no response from the starter motor, signifying that the engine will not crank. This could present as intermittent starting issues, where the vehicle sometimes starts perfectly, while at other times it may fail to crank completely. Additionally, dashboard warning lights may illuminate as the PCM detects a fault within the starter system, alerting the driver to check for issues. The presence of these symptoms indicates that further diagnostic steps need to be taken to pinpoint the exact cause and resolve the problem effectively. The first troubleshooting step when addressing DTC P16BD is to turn the ignition switch to the on position. This action powers the vehicle's electrical systems without starting the engine and allows the onboard diagnostic systems to perform checks. It is crucial to ensure that the ignition is not only in the on position, but also that there are no electrical issues preventing power from reaching critical diagnostic components. Doing this prepares the system to adequately communicate with the Honda Diagnostic System, HDS. After setting the ignition, you will be ready to follow the subsequent diagnostic instructions to effectively assess the issue at hand. After turning the ignition to the on position, the next logical step is to clear the DTC using the HDS, which stands for Honda Diagnostic System. By erasing existing diagnostic trouble codes, you allow the system to reset and check for any current faults without old codes affecting the diagnosis. This process provides a clean slate, enabling better analysis of what issues may arise during the next diagnostic check. It is essential to utilize the HDS correctly, as it can yield important information like freeze data and other onboard snapshots. If the DTC reappears after clearing, this indicates that a persistent fault is present in the system. The subsequent step involves checking the starter cut relay in the data list with the HDS. This check is critical as it evaluates the operational status of the relay under active conditions. The HDS will display specific voltage readings that indicate whether the relay is functioning correctly. An indication of 2.2 volts or less suggests a potential issue, whereas a higher voltage generally means the relay is operational. If lower voltage is detected, it is vital to proceed to the next step in the troubleshooting process, which involves further diagnosis based on poor electrical connections or assessing the integrity of the relay itself. This step is fundamental in identifying where the fault lies in the system, guiding further restorative actions. Following the check of the starter cut relay, the next troubleshooting step is to attempt to start the engine. This step is crucial to assess whether any adjustments made or preliminary checks conducted have impacted the relay's operational status. If the engine starts, this indicates that the relay may have resolved its issue, or an intermittent electrical connection could be involved. However, if the engine fails to start, you need to follow the further instructions, which will guide you to deeper diagnostics to identify the underlying problem. Each outcome serves as a critical data point in diagnosing the areas of concern surrounding the DTC P16BD. Once you have checked whether the engine starts, the next step is to turn the ignition switch to the lock 0 position. This step is crucial as it ensures all power to the vehicle systems is cut off before proceeding with any inspections or repairs. By turning the ignition to lock, you also help prevent accidental starting of the engine during diagnostics or repair activities. It's also essential to prepare the vehicle for any further diagnostics that may involve checking other electrical components, such as fuses or relays. Ensuring the ignition is fully off contributes to safety and aids in accurately validating the vehicle's electrical status. In this step, you will check the number C25 STRLD 7.5 ampere fuse located in the driver's under-dash fuse/relay box. This fuse protects the circuit associated with the starter cut relay and is instrumental in its operation. A blown fuse would indicate that there may be a short circuit or overload issue somewhere in the starter system. Checking the fuse's condition helps identify any immediate faults that require corrective action. If the fuse is intact, it points to a potential issue outside of basic circuit protection, leading you to replace the starter cut relay. Alternatively, is blown, the fuse must be replaced and reevaluated before moving forward with further troubleshooting steps that require the system to be live and operational. When you identify a blown fuse in the previous step, the next action is to carefully remove it from the driver's under-dash fuse relay box. Removing the blown fuse is necessary before you can install a new one, preventing potential circuit damage and ensuring safe handling of electrical systems. It is also important to avoid shorting out the terminals while working in the fuse box. The removal process should be thorough yet gentle to avoid damaging adjacent components. After removing the blown fuse, you will need to address the reasons for its failure before placing a new one. This step ensures that you maintain the integrity of the vehicle's electrical system and prevent future occurrences of similar faults. The next step involves jumping the SCS line using the Honda Diagnostic system HDS. The SCS line stands for the Service Check Connector, which is used for checking signal continuity and diagnostics. By jumping the SCS line, you create a closed loop in the system, allowing the HDS to communicate effectively with the vehicle's onboard electronics. This process can isolate potential faults within the starter circuit while facilitating more in-depth diagnostics. It's crucial to ensure the HDS is functioning properly while performing this action, as it could indicate communication issues if it fails to display expected data. Proper execution of this step will assist in pinpointing the source of the relay malfunction. In this step, you will disconnect PCM connector A, which is specified as a 49P connector in the diagnostics. The PCM, or Powertrain Control Module, monitors and regulates various engine and vehicle performance parameters. Disconnecting this connector is necessary for deeper investigations into continuity issues within the starter cut relay circuit. Ensuring the vehicle's ignition is off during this step is critical to avoid potential electrical hazards while maintaining component integrity. After disconnecting the PCM, you will be able to examine terminal connections, the condition of wiring, and other components involved with the relay circuit, setting the stage for the next continuity tests. Here, you will check for continuity between PCM connector terminal A28 and body ground. This test evaluates whether the circuit is complete and whether electrical current can flow as intended. A continuity check is vital, as it ensures that the starter cut relay has a proper path to ground, which plays a key role in its operation. If continuity is present, it indicates that the circuit is intact and additional inspections may be required, possibly involving the relay itself. Conversely, a lack of continuity might necessitate further investigation into the wiring or connections, which could illuminate issues hindering vehicle functionality. The next troubleshooting move is to disconnect the F connector, specifically the F on the driver's under-dash fuse/relay box. Disconnecting this connector allows for a more focused inspection of the starter cut relay circuit without external interference. Maintaining proper safety protocols is critical during this step, especially ensuring the ignition is off to prevent any electrical hazards. Following disconnection, further continuity checks between the PCM connector terminal and body ground can be performed. This process plays a vital role in identifying whether a circuit malfunction exists in the starter cut relay's operation, and ensures that the pathway for current electrical flow is complete and without interruptions. Upon completing the necessary repairs, the final verification involves a thorough testing phase to ensure that the issue associated with DTC P16BD has been resolved. First, make sure to run the vehicle and check for any reappearance of the diagnostic trouble code. If the DTC does not reappear, it indicates that the corrective actions taken have been successful in addressing the fault. Additionally, it is important to ensure that the engine starts reliably and operates normally under various conditions. This final check not only confirms the resolution of the DTC, but also reassures that the vehicle should function properly going forward. Documenting the successful test results ensures a comprehensive repair history for the vehicle. Preventive maintenance is essential for avoiding issues like DTC P16BD from surfacing in the future. Regular diagnostic checks with the Honda Diagnostic System, HDS, can catch issues early before they develop into more significant problems. It is also important to regularly inspect electrical connections related to the starter system. Loose or corroded connections can lead to intermittent faults that are often difficult to diagnose once they occur. Scheduling periodic inspections based on the vehicle manufacturer's recommendations helps maintain the reliability of the starter cut relay and related components. Good preventive practices can enhance overall vehicle performance and prolong the longevity of critical engine starting features. In conclusion, understanding DTC P16BD, which indicates a starter cut relay 2 malfunction, is crucial for addressing potential starting issues in the Honda Odyssey from 2011 to 2017. Following the outlined troubleshooting steps diligently is vital to identify the root cause and implement effective repair strategies. Through systematic diagnostics, technicians can isolate issues related to electrical connections, fuses, and the starter cut relay itself. It's also essential to engage in preventive maintenance to avoid the occurrences of similar symptoms in the future. Regular checks and maintenance play a significant role in ensuring both vehicle reliability and performance longevity. Please like and subscribe to the channel. See you next time.